Alright, today I'm going to introduce you to a concept in chemistry called the mole. Alright, so the mole is just a really big number. Kind of like how a pair is 2. What's a trio? 3. A quartet is 4. And a dozen. What does a dozen mean? What number is that? 12. A baker's dozen is 13. They give you an extra donut. And a gross is 144. The number for a mole is this giant number. 602 with 21 zeros behind it. Jeez, that's a huge number. More than billions and trillions. Okay, so how big exactly is the mole? Well, first off, we can call the mole Avogadro's number. You're going to learn more about him later on in this video. But it's 6.02 times 10 to the 23rd power. So this is the mole. Okay, or 1 mole. So how big is it? Just to put things in perspective here, there's 7.3 billion people on Earth. How many Earths would it take to equal the population of 1 mole? It would take 9.12 times 10 to the 13th power. So that's over 9 trillion, 90 trillion Earths to have 1 mole of people. If you had a mole of cats, they would create a sphere larger than Earth. Wow. If you had a mole of H2O, could you swim in it? What do you think? The correct answer is no. Because water is so small, if you had a mole of water, you would only have 18 milliliters, which actually looks like this. I don't think you could swim in that. Huh. Well, that makes you wonder then maybe, well, how small are atoms? Well, there are more atoms in 1 gram of salt than grains of sand in all of the beaches of all the oceans in the world. There's a lot of sand out there. Just 1 grain of sugar contains 1 times 10 to the 17 molecules. Each time you take a breath of air, you're inhaling 2 times 10 to the 22nd molecules of nitrogen and 5 times 10 to 21 molecules of oxygen. So how big is the mole? Go ahead and watch this video to find out.
Okay, today we're going to talk about the mole. Now I know what you're thinking. I know what a mole is. It's a small, furry creature that digs holes in the ground and destroys gardens. And some of you might be thinking that it's a growth on your aunt's face with hair sticking out of it. Well, in this case, a mole is a concept that we use in chemistry to count molecules, atoms, and just about anything extremely small. Have you ever wondered how many atoms there are in the universe, or in your body, or even in a grain of sand? Scientists have wanted to answer that question, but how do you count something as small as an atom? Well, in 1811, someone had an idea that if you have equal volumes of gases at the same temperature and pressure, they would contain an equal number of particles. His name was Lorenzo Romano Amedeo Carlo Avogadro. Wonder how long it took him to sign autographs. Unfortunately for Avogadro, most scientists didn't accept the idea of the atom, and there was no way to prove he was right. There was no clear difference between atoms and molecules. Most scientists looked at Avogadro's work as purely hypothetical and didn't give it much thought. But it turned out he was right. By late 1860, Avogadro was proven correct, and his work helped lay the foundation for the atomic theory. Unfortunately, Avogadro died in 1856. Now the thing is that the amount of particles in even small samples is tremendous. For example, if you have a balloon of any gas at 0 degrees Celsius and at a pressure of 1 atmosphere, then you have precisely 602 sectillion gas particles. That is, you have 6 with 23 zeros after it particles of gas in a container. Or in scientific notation, 6.02 times 10 to the 23rd particles. This example is a little misleading because gases take up a lot of space due to the high kinetic energy of the gas particles, and it leaves you thinking atoms are bigger than they really are. Instead, think of water molecules. If you pour 18.01 grams of water into a glass, which is 18.01 milliliters, which is like 3.5 teaspoons of water, you'll have 602 sectillion molecules of water. Since Lorenzo Romano, never mind, Avogadro was the first one to come up with this idea, scientists named the number 6.02 times 10 to the 23rd after him. It is simply known as Avogadro's number. Now, back to the mole. Not that mole. This mole. Yep, this number has a second name, the mole. Chemists use the term mole to refer to the quantities that are at the magnitude of 602 sectillion. This is known as a molar quantity. Atoms and molecules are so small that chemists have bundled them into groups called moles. Moles are hard for students to understand because they have a hard time picturing the size of a mole, or a 602 sectillion. It's just too big to wrap our brains around. Remember our 18.01 milliliters of water? Well, that's a mole of water. But how much is that? Exactly what does 602 sectillion look like? Maybe this will help. Exchange the water particles for donuts. If you had a mole of donuts, they would cover the entire Earth to a depth of 8 kilometers, which is about 5 miles. You'd really need a lot of coffee for that. If you had a mole of basketballs, you could create a new planet the size of the Earth. If you received a mole of pennies on the day you were born and spent $1 million a second until the day you died at the age of 100, you would still have more than 99.99% of your money in the bank. Okay, now we sort of have an idea how large the mole is. So how do we use it? You might be surprised to know that chemists use it the same way you use pounds to buy grapes, deli meat, or eggs. When you go to the grocery store, you don't go to the deli counter and ask for 43 slices of salami. You buy your salami by the pound. When you buy your eggs, you buy a dozen eggs. When we hear the word dozen, we probably think of the number 12. We also know that a pear is 2, a baker's dozen is 13, a gross is 144, and a ream of paper is... anybody? A ream is 500. Well, a mole is really the same thing. For a chemist, a mole conjures up the number 6.02 times 10 to the 23rd, not a fuzzy little animal. The only difference is that the other quantities are more familiar to us. So there you have it. The story of the mole, Avogadro, basketballs, and how to buy salami at the grocery store.
After watching that video, who wants to be a molionaire? Alright, so what do you think? Are we going to count every single atom? In chemistry, we don't work with individual atoms because they're so tiny, right? They're smaller than this tiny dot. We can't really measure one atom. So we have to work with lots of atoms in order to measure them in quantities that we can actually use. And that's where the mole comes in. The mole puts elements and atoms into quantities that are usable for us. So what do we mean by that? First, you have to understand what the mole is in relation to different elements. So if you find carbon on the periodic table, you'll find that the mass in grams of 1 mole of atoms is equal to its atomic mass. So in other words, remember 1 mole of anything is equal to this many, in this case atoms. That's Avogadro's number. So 1 mole of anything is 6.02 times 10 to the 23rd atoms, but it's also equal to this number here, the 12 grams of carbon. Okay? So if you find oxygen on your periodic table, what do you think? How many grams is going to be in 1 mole of oxygen? The correct answer is 16 grams. Let's keep practicing. So remember, 1 mole of anything is 6.02 times 10 to the 23rd atoms, which are really tiny. And if we want to put that into a number that we can actually use, we can convert it to grams. And so the amount of grams is equal to the atomic mass. So how many grams are in 1 mole of argon? Look at the periodic table tile over here. (39.95 grams is correct. Remember, we want to look at the atomic mass, not the atomic number. Okay, so that number tells us how many grams are in 1 mole of argon. So, what if we had a chemical compound, something like H2O? How would we figure out the molar mass? Well, all we have to do is add it all up. So each hydrogen is equal to 1 gram. I've got 2 of them, so that's 2 grams total. Each oxygen is 16 grams. I've only got 1 of those, and so that's 16 grams. In total, if I add that up, what's the total molar mass for water here? $18 grams is correct. Let's practice a few more. All right, so you'll need a periodic table. If you don't have one, you can use ptable.com. What is the molar mass of methane? And I created this table. You don't have to use a table like this, but it helps me break it down. So the molar mass, we want to look at the number with decimals here. So 12 and 1. I'm just going to round it off to keep it simple. How many carbons do I have? 1. How many hydrogens? 4. So in total, I have 12 plus 4. What is the correct molar mass for methane? 16 grams per mole. That's going to be the correct units here. G/mol. There's 16 grams of methane in every 1 mole of methane. Okay, and what is the molar mass of, it's not methane, this one. So here's more practice. Go ahead and figure out for calcium, nitrogen, and oxygen. This one's a little different because we've got this parentheses. So what this 2 does is it's going to distribute to each of these. So that tells me I have 2 nitrogens, and I've actually got 3 times 2 is 6 oxygens total. So molar mass you can find here is 40, 14, and 16. I'm going to have you do the math here. This one's easy. 40. What is 14 times 2? 28. What is 16 times 6? How about you calculate this one? The correct answer here is going to be 96. Now we want to add this all up, and we'll get our answer in grams per mole. So what is the correct total for calcium nitrate here? If you said 164 grams per mole, you'd be correct. All right, so practice calculating molar mass. Hopefully